Hello everyone, this is Raheel and welcome to part 2 of this Tic-Tac-Toe tutorial. Today we're going to be looking at winning the game, placing the pieces, and calculating when the game has been won by checking the rows, columns, and the crosses, as is our to-do list up there. Right now I'm just going to be fixing up some of the issues in the game class, like I said I was in the last video. So first things first, we're going to fix up the column logic if it's none. So I just want to make the column equal to a space if it is none. So and the column is equal to space if col is none, else just set it to whatever it usually was, and then just do that print statement. Then this logic right here, I found that a little weird. Let's just do if col count does not equal 2. That's much better. Oh, I need to indent that. Never mind. Cool. And now this one here, I found that the print statement at the end was sort of not really working, and I just want to fix that up right here. So we'll just do if row count equals 2, then we'll just print a new line at the end, and can make note that since the default in Python to the print statement is n is equal to new line, this is actually gonna print 2 new lines. And if the person wants to show the numbers, then we'll just print what we usually were going to print. And let's actually switch these two up here because there's gonna be too much space between the bottom and the top. So let's see how that looks. I'm just going to close out this other tmux window I had over here, and let's run our last Python command. Python 3 main.py. There you go. And let's make this window a little bit bigger. Oh, not that big. And let's choose our position. And there you go. That works out just fine. And you can see that the difference between this one and the last one was that the spacing is much better. Although I am seeing a bit more spacing from the bottom. So let's actually remove the new line at the very end of this statement right here. So end is equal to none, and that should fix it up on the y side. Yep, that fixed it up on the y side. Good. And the other thing I noticed in this prompt function is that this is not going to be 0 indexed, and just to make it 0 indexed, we'll just subtract the input by 1. Pretty simple, so if somebody chose the first row, it's actually going to be the 0th row, making things a little bit simpler here. And let me actually rename this function to play instead of prompt, because we're going to be using this function a lot more in a while true loop. So that's all the reformatting issues what we had in the last program. Now let's actually get started on figuring out how to play this game. So first, let's figure out how to place a piece. We'll just do define place piece. And the parameters we're going to need here is self, of course, the piece, the x position, the y position, and that's all. Then we're just going to do a one-line effect for this function. We're going to access the x position and the y position, because remember it's going to be columns and rows. Oh, I didn't x for both. That's weird. And we're going to just equal it to the piece. So we're just reassigning a position on the board through their x position and the y position, and we're going to be reassigning it to that piece. And if it's none, then that's not going to work, but we'll be able to handle that error a little later. Next thing we're going to want to do with this play function is define which piece is actually playing. So I'll just put x here, and it says expected 0 positional arguments. So we'll just do piece as an argument. So I want to say like x's turn or something. To do that, we'll just do a print statement and an f string. So that'll be piece.upper, just to make it uppercase, because that's what usually it is in x's and o's. So it's going to be like it's x's turn or o's turn. Next thing we're going to need to check is if that y position and x position already has a piece there. To do that, we'll just put an if statement. If game.board, x position, y position, same sort of stuff, is equal to none. So if that area has nothing in it, then we'll just say to place a piece, and that's just going to be the same piece, the x position and the y position that we have specified. But if there is already a piece there, so if it's not equal to none, then we'll just say print piece is already there. Please try again. And to give them the opportunity to try again, we'll just call that function again. So it'll be play and the piece that we were provided. That's pretty much it for the play function. Now to actually go into execution, we'll just put a while true loop. And we'll always start with x first, and then we'll go to o. Oh, that's 0. Yeah, so it'll just be x's and o's, and it'll be taking terms each time. Oh, I forgot to empty out the board from last time, so it's still full of x's right here. And to change that, we'll just do none for all of them. Yeah, that should work. Okay, empty board. And I want to place an X piece at position 1. Yeah, that works. And circle at, or the O at position in the center. So we're just specifying the X and Y coordinates. So let's put one on the top center. Yeah, all right, that works. Cool. So now we can place pieces. Pretty good. Now I can delete that. Now we need to track who wins the game. To do that, I'll create another function called check win. So let's do check win. And we need the board as to which board we're using. And first, let's start with checking the rows. So let's see if somebody won on the x-axis. We'll just do for row in board. And then we want to check if all of them are equal. And I'll define another function for that one because I know we're going to need to use some list magic right there. And we also need to check if all of them actually have something in them, because if we want to check if all of them are equal, but all of them are equal to none, then the game would automatically win because the board is empty by default. So we want to, and by using this all, none evaluates to false. So all of them would evaluate to false, and then all would evaluate to false, which works for us. So let's actually write our all equal lambda function right here. This is gonna be a lambda because it literally is one line. So let's just do that. All equal is equal to lambda, and then we'll take our iterable, and which is just going to be our row for now. But we're gonna reuse this lambda in a whole bunch of other places later. So iterable.count, so we'll be able to count how many times that a specific item shows up, and we just want to count the first item in that iterable. And if it is equal to the length of the iterable, or that item shows up as many times as there are items in the list, then all of the items in the list are the same. So now that all equal row function should work. And let's just display the board if that is true. Just to say, here's what the board looks like now that you place that piece. And then we'll have some sort of message later, but we won't deal with that for now. The game will just continue on. So how do I want to do the columns? I think we're just going to actually iterate through a range iterable and just use the row indexes. So we'll just write down check columns here, and we'll say for I in range 3, because there's only 3 columns per row. So we'll just assign column to something. It'll just be a list. So what's going on over here is that it's going through each row, so row 1, row 2, and row 3, but then it is going over the column that is currently selected for the for loop. So if it was for I in range 3, the I is equal to 1, then it would just be the first column. If I is equal to 2, then it would be a second column. Well, it won't be equal to 2. It's actually going to be 0 index, but just for simplicity's sake, we'll just go with that. So it'll be the same thing. It'll just be if all equal column, same sort of thing, and if all column, to make sure they're not a bunch of none values. And again, we'll just display the board for now. I'm not going to do anything fancy. Last but not least, we're going to be looking over the crosses, and I'm just going to make this one a bit more readable. So the top left is going to be TLBR, so the top left to the bottom right of the board. That's where that cross will be spanning to. And that will be specific board positions. So the first column in the first row, the second column in the second row, and then the last column in the last row. Lastly, we have the top right to the bottom left, and that'll be something similar. It'll be the first row with the last column, and same middle position, and then the last row with the first column. So that's pretty nice. We'll just iterate over these with the same for loop, and it's going to be the same process as all of them. So for cross in the top left to bottom right, and the top right to bottom left. So it's going to be iterating over both of them, even though we don't really need to do that. We'll say if all equal cross and all cross. So same sort of stuff. And then we'll just display the board. There you go. And now we have to actually provide a message for when the person wins. And we'll just do that using a winner message function. We'll just take in the piece for display purposes. And we'll print, again, the piece.upper to make it the uppercase. And we'll say wins. So this person wins. And then we're going to want to exit the program. I'm going to do this very explicitly. I'm not going to do any global variable stuff or any return values. But I probably would want to later on because this is not very good practice, I don't think. And I'll implement that in my check win function. So for the rows, I'm just going to do winner message. And it'll be row 0. So the first column in that row that it's iterated over. And then winner message board 0. So that'll be the first row. And then the first column of that row, because that's actually all we need. And last but not least, we have the winner message here, except it's going to be the exact center of the board. So board 1 and for the second column there. So now I believe this should all work. X's turn, it says, at the very top. So we'll place the X piece at the top left. Great, and then it's O's turn. But I want to see what happens when we place it in the same place. A piece is already there, please try again. All right, great, so it didn't place the piece. So now let's place the O in the center. And I want to get a cross win here. So we'll place the X piece a little off nowhere. And the O piece at the bottom. Great, it didn't invalidate or anything. And we'll put the X piece somewhere random again. And the O piece at the top. Great. O wins. That's pretty much it for this video. It looks like we've taken off all of the other things in the to-do list. So the next video, we're going to be looking at focusing on the AI portion, hopefully. Otherwise, thanks for watching. If you did enjoy, make sure to drop a like and subscribe if you want to stick around for the rest of the series. See ya!